I'm going to be giving a talk tonight called In My Humble Opinion. And it's a collection of loosely connected thoughts about recent trends in front-end development. There's a lot of really interesting and innovative stuff happening in the front-end world at the moment, and this is as good a time as any to take stock of it. So I'm going to be sharing some opinions of varying levels of spiciness, and I'm going to talk about how those opinions shape the design of Svelte and SvelteKit. I'm not here to try and convince you of anything. You'll probably find lots to disagree with me about, but hopefully this will give you some insight into how we think about our role as toolmakers. Now, it takes a certain lack of humility to stand in front of a room of people and talk for half an hour as if my words mean something. But having said that, I am very aware that some of the ideas I'll be talking about tonight have come from the brains of far smarter and more accomplished people than me. So take everything that I say with a grain of salt. These are humble opinions. And finally, while I think that the Svelte team would broadly agree with the things that I'm going to say tonight, I'm not claiming to speak for them. I'm also not speaking for Vercel, which is a healthily pluralistic company, even if we all dress the same. These are my humble opinions. I'm going to start with a fairly non-spicy opinion. There's too much thought leadership that would have you believe that JavaScript frameworks are the root of all that is wrong with the web. And if only people would make better technology choices, the web would be perfect. The only problem with it is absolute horseshit. When you last went on a recipe website and had to fight through a gauntlet of ads and newsletter modals and cookie consent banners and the recipe author's story about her childhood memories of Aunt Beryl's butter pecan cookies, and you're left thinking, if only they had used a different abstraction for creating DOM elements. No, you don't. The web doesn't suck because of JavaScript frameworks. It sucks because of capitalism. It sucks because of the attention economy, because we pay for everything with data, and because we're all slaves to the algorithm. On some level, we all know this. And so I've come to believe that as framework authors, the most impactful thing we can do isn't fixating on a kilobyte here or a millisecond there. It's empowering developers through education and documentation and diagnostics and sensible defaults to do the right thing in the face of structural forces that bend the web towards sucking it. The other stuff matters, but probably less than we think. Because every now and then, someone will show some data that proves some frameworks deliver better experiences than others. This is a chart that shows how the main JavaScript-centric application frameworks score on core web vitals measurements. You can see that only Astro and SvelteKit outperform the average website. But we have to be careful how we interpret this. For example, Astro explicitly markets itself as being designed for content sites that don't require much interactivity. And so it has a natural advantage over frameworks that are typically used for more demanding workloads. All of which is to say that as much as we love to talk about technology choices, for the most part, you shouldn't feel pressured by me or anybody else to switch away from whatever makes you productive at shipping software. Next take. Something I've seen more and more of lately is people talking about 0 kilobytes of JavaScript, as in this framework ships 0 kilobytes of JavaScript by default. The implication is that JavaScript is inherently bad, and so a framework that doesn't serve JavaScript is inherently good. But 0 kilobytes of JavaScript is not a goal. The goal is to meet some user need, or if you're cynical, to meet some business need by way of meeting some user need. And sometimes performance is a factor in how effectively you can meet that need. We've all seen the studies showing that for every millisecond delay, Amazon loses $1 billion or whatever. And sometimes you can improve startup performance by having less JavaScript. But doing so is always in the service of some other objective. Collectively, we are in danger of mistaking the means for the ends. And as we'll see later, if you want the best possible performance, JavaScript is actually essential. This is something that I see with things like Lighthouse. Lighthouse is an example of Goodhart's law. When a measure becomes a target, it ceases to be a good measure. We're incentivized to chase the green 100 at any cost. That's not how Lighthouse was originally supposed to be used. Lighthouse is a diagnostic tool to help us identify and fix issues. It is not a scorecard. So this is learn.svelte.dev, our interactive platform for learning Svelte and SvelteKit. It gets a pretty lousy performance score because in order to work, it needs to download and install Node inside your browser along with SvelteKit and then it needs to start a development server. It is doing a lot of work, and it does it pretty quickly, but not quickly enough for Lighthouse. We could get a better score by only doing that work when you start interacting with the site, but that would be a pretty serious regression in user experience. I see this pattern over and over again across all different kinds of sites. A single number simply cannot capture that nuance, and you should be wary of people who use those numbers to try and convince you of something. Most sites should work without JavaScript. This might seem like it directly contradicts the previous take, but it doesn't. These two things are both true. Number one, JavaScript is necessary to deliver the best possible user experience. And number two, sometimes you can't rely on JavaScript. A website I reference constantly is this one. Everyone has JavaScript, right? Well, those of us who live in New York are very familiar with the experience of loading a page while at a subway station, but losing connectivity before JavaScript loads. It really sucks. I believe that most web apps should be mostly functional without JavaScript. Take Google Calendar, for example. Obviously, JavaScript is useful here, but is it essential? Can I really not see my appointments and create new ones without JavaScript? The likely answer is, well, we could, but increased development cost isn't worth it. And I'm not blaming the developers for this or for the product managers for having the wrong priorities, but I do think it's a shame that the tooling used to build apps like this one don't make it easy enough to build progressively enhanced apps. Ideally, you should get an app that works without JavaScript for free, and that is something that we on the SvelteKit team strive for. For example, we server render everything by default, and we spend a lot of time thinking about how to make it as easy or easier to use forms, which work without JavaScript, than it is to use fetch. Another reason that this is close to my heart is that in my past career as a journalist, I've seen how fragile the web can be as an archival medium when it depends on JavaScript. This is Kim Kardashian's Instagram page at various points over the last decade. Early on, the site was basically just text and images, and we can look at a snapshot today and it's perfectly preserved. By 2019, you can no longer see the actual images. They're still there on her account, I checked, but because they're rendered with JavaScript, they're not part of the archive. Finally, by 2020, the growth hackers got involved, and you can no longer see anything on Instagram now without logging in. Now, maybe you don't care what Kim Kardashian was wearing in 2017, but so much of modern culture is mediated through ephemeral digital platforms that there is a real possibility that future historians will have an easier time answering the question, what was it like to live through the space race, than answering the question, what was it like to live through the AI revolution? I think that's a tragedy. 2016 is an interesting case because the content is actually there when you first load the page, but when the JS loads, it looks at the URL bar, says, hey, this isn't Kim Kardashian's profile, and just nukes the entire page. And we can go back to 2016 and fix that. I mean, frankly, if we could go back to 2016, we might have some other priorities. But what we can do is ensure that our tools today are flexible enough to continue working when unexpected things happen. So this is something that SvelteKit actually does out of the box. The client-side router will gracefully figure out the base URL when it starts up. And to demonstrate this, I've deployed a version of our docs to the Interplanetary File System, which is a peer-to-peer network for sharing files. Click on this link, that will work. It does, okay. So you can see that the URL there has this IPFS / very long string in front of it. The catch with IPFS is you don't know that string until you've generated the site because it's based on the content. So you have this chicken and egg problem. And yet it still works. The client-side routing still works. Really difficult to use a mouse when you're facing backwards at a screen. The client-side routing works, he said, without having checked it. The search function maybe works. Okay, so things are working, even though I'm on a shared Wi-Fi and it's a little bit flaky, obviously. But the point is that SvelteKit is designed to be resilient enough to work even in these fairly hostile environments. Okay, getting a little spicier. This is the first opinion that's probably going to make people yell at me when the recording of this goes on YouTube. In a couple of weeks. MPAs are dead. So for those of you who aren't captives of web dev Twitter, let me offer some definitions. A multi-page app, or MPA, is what people used to call a website. It's an app where every page is rendered by the server, and if you navigate between pages, the browser will go back to the server, retrieve some fresh HTML, unload the current document, and then create a new document from the new HTML. In contrast, a single page app, or SPA, doesn't unload the document when you navigate. Instead, a client-side router will fetch any code and data it needs for the new page, and it will update the document in place, just like any non-navigation state change. Now, advocates of the multi-page app approach have made the following claims. MPAs are faster because you don't need to load JavaScript. MPAs are more accessible. MPAs are less buggy, and MPAs can work without JavaScript. And in return, the single-page app camp says that SPAs are faster because even though you do need to load JavaScript, you're probably going to have to load some JavaScript anyway. And this way, you only have to load your analytics or whatever once instead of every single page load. And subsequent navigations are certainly going to be faster because it's much easier to smartly preload data, and you're not recreating a document from scratch on every navigation. SPAs allow you to preserve state between navigations, such as the scroll position of a sidebar or the video that's currently playing. In an SPA, navigation is just like any other state change, so you can do things like continuous transitions. There's a Vue Transitions API coming to the platform, helps with this, and it's a wonderful addition, but it only covers stuff that you can do with CSS. You couldn't, for example, tween a numeric value in a progress indicator like this if you were building a survey app. And SPAs give you a unified development model. Instead of having one language for your HTML and another for your DOM, SPAs are much more cohesive. Now, looking at these two lists, you might say, well, the stuff on the right is nice, but the stuff on the left is non-negotiable. And you'd be right. But the reality is that that list is very out of date. Modern frameworks like Next and Remix and SvelteKit don't suffer from the problems that afflicted early SPAs. And as we've seen, the claim that MPAs are faster than modern SPAs is highly suspect. I've tried to argue in the past that the distinction is actually rather unhelpful, since modern frameworks use techniques from both sides, and I've taken to calling them transitional apps because we do not need any more moronic acronyms. But this isn't why I'm saying that MPAs are dead. We're saying that MPAs are dead because Astro killed them. My Astro friends will be mad at me for saying this, but here's the proof. As of last week, Astro's roadmap includes a client-side router that would turn your Astro app into a single-page app. In the words of Nate Moore, UI persistence has surfaced as a clear missing piece in the full Astro story. Client-side routing is currently the only way to achieve UI persistence across navigation. Now, I'll be quick to point out that this is opt-in, it's not the default, but here's what's going to happen. They're going to build this thing and they're going to knock it out of the park. And if it's a simple configuration change, then people will try it even if they don't need UI persistence. And they'll discover that for the very small price of a client-side router, their apps suddenly have a nicer user experience. I would not be surprised if the default was reversed in Astro 3 or 4. So on the SvelteKit side, we use client-side routing by default. Unlike some frameworks, we don't use a link component. We just use regular A tags and intercept clicks on them. If you want to disable client-side routing for some reason, you can do it on an individual link by adding a data SvelteKit reload attribute, or you can do it for a whole group of links or even the entire document. Now, one thing that people have rightly criticized SPAs for is that they encourage longer sessions, meaning it's more likely that a new version of the app will be deployed while you're using the old one, which can cause client-side routing to fail because all of the files have moved around. So in SvelteKit, if we detect that case, we will fall back to a full page navigation, which usually fixes it. But we also make it easy to proactively detect new deployments and disable client-side routing when that happens. All right, next opinion is that explicit DSLs, domain-specific languages, are good. DSLs get a bad rap. I like them. DSLs are in contrast to general-purpose programming languages like JavaScript. HTML is a DSL, CSS is a DSL, JSON is a DSL, SQL is a DSL, regular expressions are a DSL. We don't tend to think of those as such because they're already so pervasive, and people are fine with the DSLs that they already know. But you can do some pretty cool stuff with DSLs. This is Nusi by Matthew Phillips, and it's one of my favorite examples from recent memory. It's a DSL for describing state machines, and you can clearly see how much more expressive the DSL version is than the general purpose one. This is cool, and I want to see more stuff like this. You see, fundamentally, JavaScript is an event-driven language, which means that we predominantly write code in terms of things that are changing in response to things like user action. But when we build user interfaces, we're thinking primarily in terms of state. This is the imperative-declarative split, or whatever you want to call it. So there's an impedance mismatch at the very foundation between the language that we're forced to use and the task for which we're using it. Things like JSX and hooks and signals and all the other innovations of the front-end world over the last decade or so are all in some way an attempt to resolve that contradiction by letting you write code that is state first. HTML, on the other hand, is a really good language for describing UI. There's no temporal aspect to it. It's almost like a physical substance like clay, or at least that's how I think of it. The catch, of course, is that HTML is static, so you can't use it to describe things with rich interactivity. But what if you started with HTML and used that as a springboard to create a new DSL? Well, that's basically what Svelte is. We've augmented Svelte, we've augmented HTML with state and control flow, we've augmented CSS with scoped styles, and we've augmented JavaScript with reactivity. Some people are really put off by this, and that's totally fine. For people who aren't anti-DSL, we've found that this hits a sweet spot between familiarity and novelty. We're using languages that you already know, but we're extending them in useful ways. And like with the Lucy example, we're able to express UI much more concisely this way. So I am pro DSL, but there is a crucial caveat. You have to be honest about it. In the Svelte case, we're using .svelte files. When you open a .svelte file, you're entering a kind of liminal space where the normal rules of programming are briefly suspended. And again, some people want nothing to do with that, and that's fine. I think most of us like having a little magic in our lives from time to time. But here's where it starts to get a little bit too weird for me. If you start changing the semantics of JavaScript inside JavaScript files, I'm out. And this has been a recurring theme recently across a whole bunch of different projects, and it's a phenomenon that I think deserves a little bit more scrutiny than it's currently getting. Before I give you an example of this, I'm going to tell a little story. Back in 2015, I was working on Rollup, the JavaScript module bundler, and I implemented a heuristic that I thought was pretty clever. If you weren't using the imports from a given module, like ease and transition from D3 transition there, then Rollup simply wouldn't add it to the module graph, it would just discard it. As an escape hatch, if you did need to add the module to the module graph anyway because of some side effects, then you could add the import without any specifiers, and then Rollup would include it. I was young and I was naive, and this seemed like a really smart optimization. Around the same time, the D3 community had browbeaten Mike Bostock into using a module bundler, and he basically said, fine, I'll rewrite everything in CommonJS and use Browserify. I was horrified by this because that meant the D3 bundles were going to get slow and large. And so I cold emailed him and said, hey, I really think you should use JavaScript modules for this. And tooling isn't quite there yet, but like, here's the thing that I'm working on. And that was on May 27, 2015. And on May 29th, he started filing issues on Rollup, which I didn't expect and was kind of terrified by. And this is an example of one of them. Now, Mike is the nicest, most wonderful man, and he is much too kind to put it like this. But what he's saying in this issue is, JavaScript doesn't work like that, you numpty. And he's right, it doesn't. You can't just remove modules from the graph without fundamentally altering the semantics of the code. Fast forward a few years, and some frameworks have decided that ignoring the semantics of JavaScript isn't just okay, it's actually a core selling point of the framework. I'm going to use Remix as an example, but it's not the only one. Prior to version 13, in the introduction of the app router, Next.js did something very similar, for example. And there are others. This is a remix route. The idea is that your server code, which loads data, can be co-located with your view code. When the client app is built, the loader and anything that it depends on is tree shaken away. But this isn't tree shaking, this is made up non-standard JavaScript semantics. You might think, all right, Rich, you Poindexter, who made you the JavaScript hall monitor? And you'd have a point, but it does have real-world impacts. There is actually a whole page in the Remix docs about working around the problems created by this design. And aside from the practical impacts, there's something about the blurring of boundaries between server and client that I think is inherently confusing. I've heard multiple people say that they're often not entirely sure where their code is going to end up running. More alarming to me is the possibility that you could end up with server code in your client bundle. Even Michael, who invented Remix, acknowledges that this is a real-world problem. You're one sleep-deprived mistake away from accidentally including something sensitive in the JavaScript that you serve to users. And even if you don't make that mistake, you're still prohibited from using source maps to debug your app in production because the source maps will contain the entire module, including your database queries or whatever. So why am I talking about other frameworks' design decisions? I'm not telling you don't use Remix. And I'm not saying the Remix team should make different choices. That's not my business. But oftentimes people will say, other frameworks are doing X, should SvelteKit do the same thing? And then it becomes my business. The reason for the design choice is that it's convenient to co-locate related pieces of code. Now, you don't need to sell me on the benefits of co-location. I was doing single file components back in 2014 before Vue or anyone else. I am Mr. Co-location. I love it. But co-locating code that crosses a server-client boundary in a single file is too much for me. We've prototyped it in Svelte, and it's always given us bad vibes. So in SvelteKit, we don't co-locate in files, we co-locate in directories. This is a screenshot of a SvelteKit codebase. In a SvelteKit app, each directory is a root, and each root can contain server code for loading data and view code that runs on both the server and the client. So this is actually the demo app that you get when you do npm create svelte. Inside source roots, might be hard to see because it's kind of small, there's a lot going on here. But inside source roots, we've got an about root and a sverdle root, which is a Wordle clone that works without JavaScript. The page's server code for the sverdle clone goes in a page server.js file on the left here. And any file with that suffix cannot be imported into client-side code. Your app will simply fail to build. And directory-based routing is something that we stole from Next.js, and it has a list of other benefits that's too long to get into right now, but I strongly believe that this is the way. One little Easter egg that I'll show you is that on the right, in page.svelte on line 16, we're hovering over data.guesses, and it's giving us the type and the inline documentation that we wrote on the left on line 9. So we get type safety across the network. This is the sort of thing that's made possible by embracing strong conventions. And far from being a worse developer experience, I actually find this preferable. I'll often have my data loading server code open on one side and the view code that uses it on the other. Screens are wide, but files are tall, and so it's just a bad use of real estate to try and stack everything into a single file. Okay, another example of non-standard semantics, this time from the Quick team. Quick is a framework that transforms your code in such a way that it can lazily load individual functions when it needs them and then recreate their lexical scope. It is extremely clever stuff and is worth paying attention to. Well, I personally have some reservations about stuff like this. If you move the increment function out of the block of JSX, the app breaks. If it was JavaScript, that would be fine, but it's not JavaScript, it's Quick. It's effectively a DSL for more granular code splitting. By the same token, you have to be careful about what values you reference inside that function, because in order to recreate the lexical scope, the framework has to serialize it. I mentioned this on Twitter a while back, and within a few hours, Manu from the Quick team had added a much more helpful error message so that you can diagnose the problem, because they are brilliant and dedicated. But this is really just one example of a more wide-ranging trend that I'm seeing, where in order to successfully work with JavaScript or TypeScript, you have to understand some very sophisticated transformations that are happening behind the scenes. There are some other drawbacks to the lazy loading approach, like you can't conditionally prevent an event default, which is something I do all the time, without opting out of the programming model altogether. But fundamentally, it's this mismatch between what the code does and what it looks like it does that I get hung up on. For an experiment, I asked ChatGPT to refactor the component, and at first it tried to enforce React idioms, but when I explained that we can't use state here, it made the exact same mistake, hoisting the increment function out of the JSX because it thought it was dealing with JavaScript. Another example from Solid. It looks very much like these two components should behave the same way based on our understanding of JSX and JavaScript, but they're actually very different. If you're familiar with Solid, then this makes total sense, but there's no obvious signpost here, so will people with less familiarity be able to successfully maintain this code base 5 years from now? I don't know. Maybe. I don't mean to pick on these frameworks because they're all doing really interesting and cool stuff. These are just some particularly notable examples. And, they will all point out elements of Svelte's programming model that they're not very keen on. And nor am I telling you what to think. I do encourage you to play around with these frameworks and develop your own opinion. I'm just telling you what I think. And what I think is that your scientists were so preoccupied with whether or not they could that they didn't stop to think if they should. Okay, this doesn't feel like it should be a particularly spicy take, but it does have some moderately spicy implications. Other things being equal, code should run as close to the user as possible. So the edge is better than a central server, but on device is better than the edge. Now, other things are not always equal. Sometimes you need to access your database, in which case your code should run near your database. And sometimes you need to have access to sensitive information that can't be exposed to the client. But there's a lot of stuff that doesn't fall into that category. For example, if I add a product to my shopping cart, I should be able to see that reflected immediately. Another example that we're all familiar with, when you're writing a comment in GitHub, you can't preview it without sending the comment to the server so that it can render the markdown. Sometimes it's pretty slow. You can absolutely do markdown rendering and syntax highlighting in the browser. Maybe you'd want to be lazy about loading the grammars that you use for the syntax highlighting, but it is a very solvable problem, and it will provide a much nicer user experience. And this isn't just about latency, it's also about resilience. I travel by Amtrak a fair bit, and every time I do, I'm like, great, 3 hours of uninterrupted work. But then I keep running into things like that because my connection is so flaky, and so most times I'll just give up and read a book instead. It's not just Amtrak, it's also every time I'm on the subway, or even when I'm walking down the stairs to leave my flat and my phone switches from Wi-Fi to cellular just as I'm trying to look at the details of where I'm supposed to be going. Turns out we're pretty bad at building things in an offline first way at the best of times. All of this is why I'm personally a little bit nervous about React server components. For those of you who aren't aware, RSC means that your UI is rendered on the server by default, and only components that have a special use client directive will run in the browser and have access to things like use state and use effect. Server components and client components have different APIs, they can use different hooks, and there are restrictions on how you can combine them. But the upshot is that by default, in the future, your React app will run entirely on the server and you will opt in to client rendering for specific parts of your app. Now, clearly this has some very substantial benefits. This is hugely important work, and frankly, it blows my mind. But I do worry that we'll become so paranoid about serving JavaScript to our users that we're overcorrecting. If the default for interaction is to require a server round trip, for client components to be implicitly regarded as something to avoid, then the net result could be slower and less resilient web apps. I might just be fear-mongering here, I don't know. Dan Abramov is probably going to do a withering tweet thread on why I'm wrong about this. But I'm very curious to see how this is all going to look in a couple of years with the benefit of hindsight. Okay, another spicy take. We will regret reinventing RPC. RPC stands for Remote Procedure Call. It's an idea that has been around since the 70s. Basically what it means is that instead of passing a message to a server and waiting for a response, you call a function on the server instead, and the RPC protocol takes care of the actual message passing. In effect, it allows you to pretend that a distributed system is not distributed. You're just calling functions. Now, back in the 80s, people were calling the wisdom of this idea into question. This 1988 paper by Andrew Tannenbaum called A Critique of the Remote Procedure Call Paradigm is very much of its time, but it's still worth reading. Some arguments can't be serialized correctly. Serializing closures is particularly hairy. If the server mutates arguments, that mutation won't be respected on the client. Network errors and logic errors all kind of get smushed together. All of these things are easy to deal with if you're not hiding the implementation details. But over the past few months, RPC has had a bit of a renaissance in the front-end world, except that we now call it server functions. I first saw it in Solid Start. The idea is that you write code like this, and oh, hang on, the write code like this. I'm going to have to try and remember my slides because I messed this up. And the compiler sort of waves a magic wand and you can call code on your server as though it were a local function. So the ergonomics of this are undeniably really nice. You even get type safety because as far as TypeScript is concerned, it is just a local function. But a while back, Jason Miller, the creator of Preact, did a tweet that I found quite interesting. He said in effect that these abstractions are dangerous. I hope he's wrong, but I think he might be right. Like if we take this example here, this server function looks and feels like an internal implementation detail, but it's not. We've actually made an HTTP endpoint that anyone can call with any data. So TypeScript is telling us that field can be name or quantity, but in reality, it could be name, semicolon, drop table users. If you know, you know. So when you make an endpoint explicit and you're working with form data, you're aware on some level that the data is untrusted. And so, I think you're much less likely to make this sort of error than if it looks like a private function call. And you might be thinking, Rich, come on, I would never make that mistake. But look to your left and look to your right at the people around you. Do you trust them not to make that mistake? I don't know. Bear in mind also that if you use source maps for debugging and they contain the original server code, you're basically handing attackers a diagram of your defenses. This shit makes me very nervous. So people have asked us to add this to SvelteKit, and we've said no. Maybe one day, once enough people have fucked around and found out, we'll do it, but not yet. We think that part of our responsibility as toolmakers is, to the extent that we're able, to help protect you and your users against these sorts of issues. So SvelteKit has built-in CSRF protection, it has CSP primitives, and we don't do things like that just because they feel convenient. Okay, I'm rating this one low on the Scoville scale, even though it seems like an unpopular opinion, because I think it's actually pretty obvious. Build steps are good. There's this idea that comes up every now and again in front end that build tools are the devil's work and that we would all be much better off without them. This is a recent example that gained some traction from the Dino blog, and it's one of the better versions of this argument that I've seen. Normally they're a lot angrier. But the thing that often gets missed in discussions about build steps is that they primarily exist for a user's benefit, not for ours. Build steps let us minify code. They let us combine 100 small modules into 10 coarse-grained chunks that load faster. They remove unused code from client-side bundles. They optimize images. They hash assets so that they can be cached immutably. They guard against bugs by type checking and linting. This is all stuff that directly results in a better user experience. It's true that build steps also benefit developers by letting us use non-standard dialects, easily import dependencies and things like that. But if you remove build steps, it's user experience that suffers more than developer experience. And yet, interestingly, if you look at the people who complain most vociferously that our industry prizes DX over UX, and then look at the people who want to get rid of build tooling, there is a striking overlap. It's hard not to conclude that it comes more from a reflexively anti-tooling mindset than a genuine concern for users. Here's another example of a build step being really beneficial that I didn't get around to doing a slide for. And all of the code snippets in SvelteKit's documentation are type checked against the SvelteKit source code. So, for example, this code down here is checked at deploy time to make sure that it doesn't contain any errors and that it's up to date with current types in SvelteKit itself. And that unavoidably takes time. One of these pages might take several seconds to render on this M1 MacBook Pro. So we pre-render this content at build time, as well as ensuring that we don't publish incorrect documentation, because if we do, the deployment will fail. It means that everyone visiting this site gets content instantly. If we did that rendering on demand instead, then even if we had incredibly sophisticated caching, some users would end up having to wait multiple seconds for the page to load, and that is just not acceptable. So, build steps. You might not need one, but you should probably have one anyway. Okay, my final take of the evening is that none of this matters. I don't think AI is going to take all our jobs, but I do think there's a better than even chance that it's going to change them beyond all recognition. Might not be long before talking about these sorts of code preferences feel like talking about what implement you want to use to make holes in your punch cards. So for the few weeks in which any of this is still relevant, let's have interesting debates and share our ideas, but let's not take ourselves too seriously. And let's have fun building stuff however we like to build stuff. That is my time. Thank you for hearing me.